Okay, everybody, it's Friday, and today's lesson is about making a standardized solution. A standardized solution is a highly accurate concentration, and you're going to be watching a video after this teaching video of Mr. Zielinski, aka Z-Dog, and I awkwardly do a lab that makes a solution. Sadly, this would be a lab you guys would get to do in class, but because we're on isolation because of COVID-19, you get a very awkward video shot by your teachers. Okay, so let's start off with the math part, because in order to make a solution, you actually have to weigh something. You can't just decide to weigh moles, so you have to use the molar concentration unit analysis that we've already done on Wednesday and Thursday. So the question here is, we have to make a 100 milliliter solution of copper sulfate pentahydrate, it's the compound, at a concentration of 0.1 moles per liter. Okay, so this is a unit analysis question. That's what we're going to do, unit analysis. We're going to write down what we know. Okay, we've got, I'm going to turn the 100.0 milliliters into liters by dividing that by 1,000. Okay. 0.1 mole per liter. And guess what? What goes with, if we're trying to find mass, we need molar mass. Because in order to make this solution, it doesn't say it, which is kind of tricky. In order to make that solution, we need to weigh out the copper sulfate pentahydrate. There should be a little dot there. Okay, so let's get the molar mass of that. That's 1 copper. Copper is, where are you, copper? There you are, 6355. Okay. Add 2 sulfur, 3207. And then we've got 4 oxygens. Perfect. And then I'm going to add all of that molar mass to 5 waters. So I'm going to add up a water separately. So 6 oxygen and 2 hydrogens. Okay, I get 249.72 grams per mole. Okay, so this is going to be very similar to the questions that we did on Wednesday and Thursday, where in order to get mass, we start with the molar mass variable. Get rid of moles by putting moles on top. So we're going to use the concentration next. Okay, our mole will cancel out. Mole cancel, mole cancel. And then I'm going to get rid of liters with the volume. Liters cancel. Okay. So when I multiply that out, I get 2.4972. We need to round that to 3 sig figs, because 3 sig figs is our least accurate value. So this is silly pen, 2.50 grams. All right, so that's the mass of copper sulfate that we have to weigh to make this solution. But in order to make a solution, you have to go through a series of lab steps. Okay? We've already done step 1, which is calculate the mass needed. Okay? What do you think step 2 is? Once we're done calculating the mass, how do we get the mass? Well, step 2, spoiler alert, after we're done calculating the mass needed, is we have to weigh the mass. And I'm going to cheat a bit. I'm going to put another step with step 2, weigh the mass and dissolve in half the volume you need. So we needed 100 milliliters. So we're going to dissolve that mass in 50 milliliters. Now the video, the very amazingly awkward video you're going to watch of Zielinski and I shooting how to make the solution, I'll explain, I think that's my part, I'll explain why it's important to dissolve it in half, not the full amount. In step 3, we're going to transfer this to a volumetric flask. coronavirus. Okay. A volumetric flask is a very special flask. You'll see us using them. They have a long, skinny neck, and they have one gradation line. So there's only one line on these flasks. And all the flasks do is measure one volume very accurately. And ironically, the flasks we're going to use measure 100 milliliters only. That's it. They only measure 100 milliliters. Step 4 is we're going to fill the flask to the gradation line. I call it the meniscus line. Mr. Z calls it the gradation line. And that's going to be with distilled water. Okay. Now, there's a couple little things you can do after that you're going to watch in the actual video where we shoot. But what you'll find, and it's kind of tough to see on the video, but what happens as you fill the flask, the water, well, that's a terrible flask. Let's try again. Oh, a little bit better. Okay. As water fills the flask, okay. Whoops. Okay. All right. As water fills the flask, it has hydrophilic forces to the glass itself, and it starts to have this curve. As you get towards that gradation line, the very bottom of how the water curves has to be at that line. So what will happen is if you don't fill it up enough, see, I'm going to move, let's say this is the water and it's filling up. Okay, that flask isn't full. But if you can't move the gradation line. But if you fill it and the meniscus is right at that line, that's actually perfect. It looks like you've overfilled it. But you want that bottom to be right at the meniscus line or the gradation line. Okay, I hope you guys enjoy the video that's coming next about how to actually make a solution. Now, you can watch part of that video where we make the solution, and then you can watch the dilution part of it. I'm going to split it into actually 2 parts. So you can watch the video next where we make the solution.